Hello guys.
Oh,
So Robin Roy and Prashanti Chakraborty and Jaber are here. So how are you guys doing today?
um, quite fine. And how are you? How is going on?
For me, I just woke up.
It's difficult for you to join the classes. It is morning in your country.
Yeah, yeah, it's hard, but like there are many kind of reminders I get actually. So some people would call me, and my mom would call me as well.
Yes, in
Or
Bangladesh,
yeah,
many of us usually wake up at 11 a.m. or 12 a.m. So it must be difficult for you to join in morning.
yeah. In that sense, it's difficult, but 11 a.m. like yeah, when I do not have any task or anything, then I'm at bed until up to like past 10. But now, like, I have to be really on time, otherwise, this anxiety disorder will catch up. I have to wake up early and go to bed at early.
Yes, I try, but cannot maintain.
For me, I have to do it. There is no other option. So, how many are here already? Uh, Arafat Hossein, Humaira Binte Awal, Jaber Ibn Taher, Prashanto Chakraborty, Robin Roy, and Sifatul Alam Sifat. Okay, just wait for a few more minutes. In Bangladesh, there are two occasions today, so yeah, people might be busy.
I think that's why the attendance is that low.
Yeah, it might be the reason. I think they will show up. People will show up, but they might be a little bit late. That's all. I'm going to wait for 2 more minutes and then I'm going to start it anyway.
Okay.
So Maruf, are you here? Maruf? Please wait for 1 more minute, then we'll start. Okay, so I need to mention a few things. First, maybe next class or the class after, we are going to use Mignathor and Wheeler. So please collect your copy as soon as possible because we are going to use it. And I'll set problems from there as well. So it's better to have a copy. You can download the PDF version as well, but I don't think it's that much comfortable to work on a PDF. So please have a hard copy. That's one thing. And another is there is a workshop. There's an upcoming workshop. It's organized by some Docs Pro Limited or something at India. So Committee of Physics is a kind of collaborator here. So they want like the students at CP will get a discounted rate. So for $5, I believe, for $5, the usual the price is like $6.25. So as a CP student, you'll get a discount. So I think it's better to join. It's about like cyber security and that kind of like technological things. There are 4 workshop, like 4 segments in total. So I can provide you the brochure. You can look into it, like if you're interested. If you're interested, then I can provide the brochure. Point is, we do not have any computer science major here, so probably not many will be interested. But as you're getting discount anyway, so you can join it. Okay, what else? Oh, yes. We can start at least. It's 9:09. So happy Valentine's Day, everyone, and Shubho Pohela Falgun in Bangladesh. So how's everything going? And what were we doing the last time? What was the thing we were doing last time?
Two-body problem.
Yes, we were doing two-body central force problem. So did you guys have a chance to look into it, like review it or something? Because for today's class, it will be easy, useful if you just had looked into it.
Yeah, I did.
Okay, good. Who else? Okay, so last time we used Newton's law. And Lagrange's equation. To produce the equation of motion, right?
Yes.
Produce the equation of motion. So can you guys remind me a little bit what was the equation of motion? What were those? The differential equation of motion? Tell me the Lagrangian version, like when we did the Lagrangian, that's a little bit integrated format. So it's better to work on that. Just tell me the equation of motion that we derived last time. Just tell me the equation of motion, because I don't have those here.
Okay. So at first I have to tell the Lagrangian version or Newton.
Okay, yeah. Tell me Lagrangian.
DDT.
DDT.
R square theta dot. DDT of R square theta
DDT
dot.
of R square theta dot.
Equal to
R
square sine theta cosine theta phi dot square.
R square sine theta cosine theta
Phi dot square.
Squared.
Yes.
Okay. Then
Then ddt of
there should be more terms here.
uh,
Okay. Sorry. It's the theta equation you're telling me. Tell me the r equation first. Tell me the r equation.
radial. Okay. So r double dot
Okay. Yes. R double dot
minus r theta dot square
minus r theta dot squared
minus r sine square theta
minus r sine squared theta
times phi dot square
multiplied by phi dot square
plus gm by r square equal to 0.
plus gm by r squared equals to 0.
Yes.
Right? Yeah. Looks
Uh,
good. I think that's correct. Yeah. Then
then ddt of r square theta dot
ddt of r squared theta dot
r square sine theta cosine theta.
equals to, right?
Yes.
Equals to r
Yes.
squared
Sorry.
sine theta
Cosine theta times phi dot square.
phi dot squared. Okay, great.
Then ddt of
Ddt of,
mr square sine theta
actually we cancelled the m on both sides, so
uh,
r square
sine theta phi,
sine theta
phi dot equal to 0.
phi dot equals to 0. Okay, so these were the equation of motion. Also, like, please remind me the Lagrangian as well. So I think that would be helpful for me. So the Lagrangian of the system. Okay, let's write it down on the top. Okay, so Lagrangian of the system, the whole system, like not just like this separation part, like including the center of mass part. What was that? I believe it was half
Uh,
m big
yes.
r dot squared, right?
Yes. Half big M big R dot square
Yes, so I am going to write it like this: big X dot squared plus big Y dot squared plus big Z dot squared. This is basically big R dot squared. Then I'm going to write the other part in polar form. So another part would be like 1 over, like half m, then r dot squared. Let's write down on the bottom this part. Okay, here plus half, then I believe r dot squared plus r square theta dot
R
square
theta dot square
plus r square sine squared theta
times phi dot square.
multiplied by phi dot squared. Yeah, right. What else?
Phi dot square. Yes. Then plus gm time small m times capital M divided
Plus
by
or
R.
minus?
Plus.
It's plus. So plus
Yes. Plus g capital M times small m divided by R.
G capital M small m divided by R. So that was the Lagrangian, right? And we found the Lagrange's equation and we kind of solved it as well. So we did not stop at that point. We actually integrated part by part and found a solution as well, right? Could you please tell me the solutions? Solution for R, solution for theta, solution for phi, like that. So what was the solution for R?
Solution for R equal to R of T epsilon R and R naught.
No, there is an integral version that I want.
Okay.
Integration over R. T equals to something. It was like T equals to integration R0 up to R, like that.
dr
dr
Divided by under root
Yes, it's root over
twice of what was that? Zeta? I don't know.
twice of
And,
zeta.
no, what was that? The symbol I forgot.
I think
Mm.
curly E. That means energy per unit mass.
Okay. Yeah, it's E. Yeah. So twice E.
Yeah, plus twice GM.
So okay. So for everyone's convenience, so E and zeta, those actually xi that can be confused. So xi is written like this. See, and E is written like this.
Okay.
Okay. So the first one is xi and second one is E. Okay. So twice E.
Yeah, plus twice GM by R.
Twice G M by R.
Yeah, minus L square by R square.
L squared by R squared. That's all right.
Yeah,
Okay, great. Then we had also an equation for like that connects R and theta as well.
that was theta is equals to
Yes, theta equals to
integration 0 to t
integration 0 to t
L by
L by
R.
R. Oh, okay.
R square, I mean. Yeah, because
Yeah, I know. So this is what you want to write. Okay,
yeah, dt.
dt. Okay, so here actually we mean that R is a function of time, right? So you need to know this thing to figure out this one, right? So the basic equation actually we are going to use here, actually we are using here is that R square theta dot equals to L, right? That's basically we are integrating here.
Yeah,
Okay, so also we had another relation between theta and phi as well, like, or the result for phi, what was that?
phi equals to phi naught.
Phi equals to phi naught.
I think that's it. No?
Oh, okay. We chose a specific case for phi. Yeah. So if we chose something, then it's okay. But if we did not, like we wanted a general solution as we did in Newtonian case, what was the solution? This is one possible solution, like one possible solution.
This is phi equal to
Phi equals to
uh, integration of dt,
okay.
integration from 0 to t Lz divided by r square sin square theta.
0 to t, are you sure? 0 to t Lz.
Yes,
Divided by
r square sin square theta.
r square sine square theta. Okay, yeah.
T.
Yeah, dt. Yeah, yes. So basically here actually we are integrating the another equation that is r squared sine squared theta phi dot equals to Lz, where we are considering that r and theta are time. Like you need to perform these two integration first, then you'll know what how r depends on t and theta depends on t, and then you can integrate for phi, right? Or you could choose a specific solution for phi and just go with that. Okay, so far so good. We had this, but what kind of physics does it tell? What physics does it tell us? Like what we know from it? It's hard to tell. It's hard to tell like what to do with these equations. Like, yeah, if you have numerical integrating system like a computer algebra system that can integrate this kind of thing, you just input it and find the functional relation and plot it. Then you'll understand. So that's one way.
I have a confusion about the third equation of motion. Should there be sine square or sine?
I think there should be sine squared theta. I wrote it already, but it's not taking.
Yes, it is sine square.
Yes, it's sine squared. Okay. So these were the equation of motion, and but to extract some physics, to understand some physics, actually it's better to have a relation between angular coordinate and the r. That would be a better way to think about it. So to do that, actually what you can do is we can actually substitute all those time derivative instead of that. Like we can substitute for those time derivative and have a theta derivative of phi derivative of r, and solving that equation we will get a relation between r and phi. So our goal is now like find a relation like this for fixed phi, or r equals to r of phi for fixed theta, right?
Yeah.
Also remember one thing, that we are actually simplifying the case. Like here we chose a specific case, like one possible solution is phi equals to phi naught, like phi doesn't change. So that one possible solution, actually it's not general, right? So when we have a general solution, then actually we expect like this. Say r is a function of theta, that's fine. Then say theta is a function of phi, and also time is a function of r, like that. So the last equation here, it connects how theta and phi are related. The other one connects how theta and r are related, and the first one, it connects like how time and r are related. Then you know everything. So when we do Hamilton-Jacobi, we'll automatically find this set. This set will be found automatically. We do not have to do anything when we do Hamilton-Jacobi. So for now, we have to choose a specific. Actually, we need not to. We can keep it general and go with it, but the mathematics will be a little bit difficult. That's all. So I am not like interested in doing like complicated math here. So let's keep it simple. So let's choose one of those, either this one or that one, and have a relation between like r and phi or r and theta. So which one do you want to do? Fixed theta or fixed phi?
Fixed phi.
Fixed phi, as I did the last time, right here.
Yes.
Okay, let's do the fixed phi solution. We could do the otherwise, like the other way we could do that. That's also same, so it doesn't matter actually. Okay, so for fixed phi, so if we choose this solution, phi equals to phi naught, then phi dot, it's automatically 0, right? 0 for all time.
Yes.
If you substitute that here, this equation is automatically satisfied, right? Because phi dot is then 0, then ddt of 0 equals to 0. That's for sure.
Yes.
So we need not to worry about the last equation anymore. All we need to work with these two equations.
Yeah.
Okay, so let's substitute phi dot equals to 0 everywhere. So if I do that for the first equation, it gives me r double dot minus r phi dot squared minus r sine squared theta. Oh, that becomes 0 actually. These terms become 0. So it becomes like r double dot minus r phi dot squared minus r sine squared theta phi dot squared. What I'm doing? Sorry. Plus gm by r squared. That what I want to write equals to 0. Okay, so this is what I want to write, and also do the same thing for the other equation. This one, if you do that, what do you get? ddt of r squared theta dot equals to 0 because you have phi dot here. So you get another equation is ddt of r squared theta dot equals to 0. So you need to integrate these two equations because you have already integrated the another one and you got solution like phi equals to phi naught constant phi equation.
Yes.
Okay, so we can do the same trick we did last time. First integrate this equation and substitute back and have a first order equation in R. I think that's the easiest way to do this. Actually, you could do in another way. We'll see both ways. Let's see both ways. So if you first we are doing integration. So we have two ways, integration ways, and another is solving differential equation ways. So let's do the integrating way. So if we integrate this equation, the second one, ddt of r squared theta dot equals to 0, that gives us r squared theta dot equals to some constant, and we already know from last class that that's going to be the total angular momentum per unit mass for the system, right?
Yeah.
Yes.
So okay, that's good. And for the other one, we need to substitute theta dot over there. So that gives us r double dot minus r. What is theta dot now? Theta dot is now L divided by r squared, right?
Yeah.
Okay, so now we have r double dot minus L squared divided by r cubed plus gm by r squared equals to 0. So it can be made a total derivative if we multiply it by r dot. So if you multiply by r dot, this thing, if you multiply by r, actually twice r dot, that's what I mean. So it gives me twice r dot r double dot minus twice L squared by r cube r dot plus gm by r square, actually 2gm by r square r dot equals to 0, right?
Yes.
So the first term, what do you get?
It will be ddt of
It's ddt of
r dot squared.
ddt of r dot squared, right? Then what about this thing?
It is ddt of L square by r square.
It can be written as ddt of L squared divided by r squared, right?
Yes.
What about the last part?
It is negative gm by r.
Negative ddt of 2gm by r, actually.
Yes. Okay.
Take derivative in your
Yes.
head, and we'll see this. Okay. So basically, the equation we got last time, ddt of take half inside, so we get half r dot squared plus half L squared by r squared minus gm by r equals to 0, right? This is the equation we got. Remember last time we did the same calculation last time. Actually, I'm repeating some stuff because
Yes.
probably forgot. Okay, so integrating this thing, and we recognize the terms, this thing as the radial kinetic energy, this thing as the angular, total angular kinetic energy, and this part like negative gm by r, that is basically the total potential energy of the system. So basically you can identify the integral to be a constant that's the system's total energy per unit mass, right?
Yes.
So that we wrote as like that cursive E, this thing.
Yes. Total energy per unit mass.
Yes, total energy per unit mass. Okay, great. So now, now we are going to actually, here we have a time derivative of r, right? So let's write it down explicitly. So we have it here like half dr over dt whole squared, right?
Yes.
We have. But if we want to integrate r as a function of phi, or actually theta here, then we do not want that dr over dt term here. We want dr over d phi instead, right?
Yeah.
Yes.
Okay, great. So by chain rule, we know one thing, that dr over d theta is nothing but dr over dt divided by d theta over dt, right? So which is nothing but like r dot divided by theta dot.
Yes.
Okay, so actually we are trying to substitute like r dot over there. So so let's solve for r dot. So r dot is nothing but theta dot dr over d theta, right?
Yes.
Okay, so we know the relation between theta and r, theta dot and r, that is r square l equals to sorry, right? So it should be like r square theta dot equals to l, right? We know the relation.
Yeah.
So if you use that to solve for theta dot, that would be l by r squared, and you substitute over here. So r dot is nothing but l over r square dr over d theta, right?
Yes.
Okay, but there is a problem. Problem is, even if you substitute this thing on here, like the integration would still be difficult. It won't be that easy still. So what we do, we recognize few things, that if you have a variable and you differentiate it, so here like dr over r squared, you get this kind of thing either by differentiating like 1 over r, right? Like you can actually collect this thing to be like l is a constant thing, so don't worry about that. So negative l, and then d theta over 1 over r,
Yes.
right?
Yeah.
That's what I write instead. Just take the derivative inside your head and you'll see this. Also, all of those r that appears as like 1 over r or 1 over r squared. So it's better to take 1 over r equals to something. So if you do that, like let's take 1 over r equals to u. So then our r dot is nothing but negative l du by d theta, right?
Yes.
And that equation becomes like half r dot squared. That's fine, we're going to substitute that later. But for for the other part, it becomes like half L squared. Then we had divided by R squared, so we now have U squared, right?
Yes.
Like that.
Yeah.
So now substitute that R dot over there. So you get half L squared du over d theta whole squared plus half L squared U squared minus GMU equals to E, right?
Yes.
Now do the algebra. Solve for du over d theta whole squared. What do you get? So you have to multiply by 2 everywhere and then divide by L squared, right?
Yes.
So you get 2E as we multiplied the whole thing by 2 and then divided the whole thing by L squared. Then we have another plus GM, actually 2GMU by L squared. And then finally we have negative U squared, right? Do you guys agree?
Yes.
Okay, okay, great. Then what we can do, like, see, this whole thing is a function of U only, right?
Yeah.
So what we can do, we can take square root and do a little bit of algebra and simplify this thing, right? So if you do that, did I miss something, some term? I should have 4 terms. 1, 2, 3, 4. Yeah, 4. Yeah, I have 4 terms. Okay, great. So du over d theta is nothing but square root of that thing, 2e by L square plus 2gm u divided by L square minus u square. Actually, I'm going to write that u more explicitly over there. Okay. Okay. So what you get, integration over u divided by square root of twice e divided by L squared plus 2gm by L square multiplied by u minus u square equals to integration over theta. So we can consider, like, when theta was 0, the position we can call it like, actually we don't need to, actually let's consider it to be a indefinite integer, so let's add something as constancy. You can do that as well. So can you integrate this thing?
Yes.
How? Can you integrate that part?
At first, I can consider it
Okay,
as a.
so you know this form, integration is dx over a squared minus x squared. Can you integrate this thing?
Yes, from 0 to
Yes. Yes. Sine inverse x by a, that would be the result, right?
a. Yeah.
So here we want to make a method of like, we want a complete completer square. Like here we have u minus u squared term, like something u minus u squared. Instead of that, we want something variable whole squared. That's what we want. So do the simple trick. So here, this side, let's write it down. Theta plus c equals to actually, from now on, I'm going to, instead of writing 1 over square root, I'm going to write whole to the power negative half. That would be easier. So twice E divided by L square. And then you have plus 2gm L square U minus U square whole to the power negative half du, like that. So this is your if you factor out this minus term, this is going to be your x square, like a square term. Now you have your twice ab term as well. So what is your b here?
GM by L square.
Gm by L squared. So that's what we are going to add and subtract. So actually subtract and add. So let's subtract first. So negative Gm by L square O square and then add. Right?
Yes.
Okay, so you can write like this. Integration twice E by L squared plus G square M square by L to the power 4, and then minus, if you factor out the minus, this can be written as whole squared. Whole square of what? So it's going to be U minus Gm by L square whole square, right?
Yes.
So this is now your new variable that like is in a compact form, like U minus Gm by L square. So if you consider that U minus Gm by L square equals to W, if you consider that, then dW is going to be the same thing, right? dW equals to du, but
Yeah.
this term is going to be just W squared. So we can write like that. So, and also let's consider this thing to be some A squared for now. So it's going to be A squared minus W squared whole to the power negative half dW. And that's going to be, when we integrate that, it's going to be sine inverse of W by A, right?
Yeah.
Now we can substitute everything back. So the solution we got, theta plus C, where C is an arbitrary constant, equals to sine inverse of, what is W? It's U minus Gm by L square, right? And what is A? A is nothing but twice E by L square plus G square M square divided by L to the power 4. Is that correct?
Yes.
Oh, sorry, no, it's not correct. The square root of that thing.
Oh, yeah.
Everyone happy so far?
Yeah.
Okay, great. So what we can write is as, if you multiply this thing by on the other side, like take sine of this thing, so it becomes sine of theta plus C. And if you multiply by that thing, so you get twice square root of twice E by L square plus G square M square divided by L to the power 4. That's what you get. And on other side, you have U minus Gm by L square.
Yes.
Okay, great. And what's U?
1 by R.
1 over R. So yes. So this is the relation between theta and R. So can you recognize it? Is it something that we should know? Like know the shape of?
Ellipse.
It's an ellipse, but at least I cannot see it. So we need to simplify. We know for an ellipse, a standard ellipse that looks like this. I posted some video, like gave you some link. If you saw that, then if you have an ellipse that looks like this, then it has a form of r equals to something divided by 1 plus another something cosine theta plus or minus something. It should look like this. So let's try to make it into that form, then we can discuss. So what we can do, like how can you convert sine to cosine?
Pi by 2 shifting.
Add pi by 2, right?
Yes.
So sine of theta plus pi by 2 equals to cosine theta, right?
Yeah.
Is that correct?
Yeah.
Okay, so we can write like this: sine of theta minus delta plus pi by 2, where our delta is negative delta equals to c minus pi by 2. It is just
Yes.
the initial value of theta, that's all. Okay, so this term directly can be written as cosine of theta minus delta, right?
Yes.
Cosine of theta minus delta with the new definition of delta, that like delta equals to pi by 2 minus c, that's all. So previously c was the arbitrary constant, now delta is the arbitrary constant. Okay, and what else? Actually, it's already in the form. So we have like square root of this blah blah blah. And if you take this thing on the other side, it gives you gm by l square as an additive term. So this is what you get. So if you invert this whole thing, you get 1 over r equals to 1 by this whole thing. Gm by l square plus square root of twice e by l square plus g square m square divided by l to the power 4 cosine theta minus delta. So for the standard equation of ellipse, this additive term should be 1. So we divide, like we take this thing on the top, so we get L squared divided by GM, right? If we take
Yes.
and then we have 1 plus what?
1 plus root over
Yes, we have to divide it by
gm by l square.
yes. Yes, GM by L squared, yeah. So we get square root of this part, it gives you 1, right? It gives 1,
Yes.
then plus
Plus
twice
epsilon 2 l square
L squared divided by
g square.
G square L squared, right?
Yes.
Okay. So this is the standard form of an ellipse, where for an ellipse we have here this factor. This is the shape factor. It determines how much is that, like how big it is. So let's call it d, and actually d actually here is something else, right? directrix distance, right? So actually it's usually written as epsilon multiplied by d and 1 plus epsilon cosine theta minus delta, right? This
Yes.
is a standard form. If you watch the video, you should know. So for this case, we can compare it and find what epsilon is. Epsilon is nothing but square root of 1 plus twice EL squared divided by G square M square.
So E must be negative.
Yes, yes, E must be negative. Otherwise, it's not going to work. Actually, it can be positive. E can be positive as well. But
Yes, but in that case, the shape will be like parabola or hyperbola.
it will be hyperbola actually, not parabola.
Yeah, hyperbola. Parabola in case of E is equal to 0.
Okay, so let's see those cases. So for ellipse, we know that this epsilon, if it is 0, then it's a circle. And it's easy to see, like if this epsilon is 0, then we just have r equals to, okay, did I made a mistake? I think there should be something else. Because this epsilon is, if this thing is 0, that thing becomes 0 as well. It's 1 plus something like that.
I think
Just figure out the standard equation. I think in terms of epsilon, it should be something else. It's usually a separate constant that we usually write.
yes.
I think it's 1 plus epsilon, d into 1 plus epsilon. That's what it should be. Just look into it. Is this correct? 1 plus epsilon into d?
What is D here?
D is the distance of directrix axis, like this
From
from the center, yeah.
okay.
So from the origin, like it looks like this, and D should be here. So this distance actually is D.
So basically, D is equal to A by E, and
D equals to A by E. Is that correct?
yeah, since E is less than 1, so A by is greater than A. From center, I'm assuming, but if it is from focus,
Okay, let me take it. Like
if D is measured from focus, yeah.
Let me check it. Actually, it's, I forgot the standard form. So in Taylor, it's written as just as a fixed constant, like C, like that. But I know there is a relation between that constant, directrix, and the eccentricity. So that's what I need actually.
Well, we can check what it means.
Okay, yeah, I got it. I got it. E equals to A, but we need C. Where is D?
Well, if del is equal to 0 and theta is equal to 90 degree, then r should be r can be expressed in terms of the semi-major axis and eccentricity, and thus we can find a geometric meaning of
Yes.
capital
Yes,
M.
the problem is like when we write in this form, like this is also ellipse, x square by a square plus y square by b square equals to 1, right? This is also ellipse, but problem
Yeah.
is our center is then like center of this like r
Origin.
equals to 0 point actually.
But here the
Here actually
center is
one
focus.
Yes. So that's how much we need to
Yeah.
shift it. So from the diagram, as I can see, this distance is actually d, right? So when it is like considered from the focus, so this like translating d amount, it gives me this form. But I need a direct relation between c and that constant that I have written, a equals to something. Could you please look up and pull out the relation between this a and we can actually derive it as well. That's true. But it will take some time. That's it. Okay, let's derive. So we have the relation like this: r equals to some constant divided by 1 plus epsilon cosine theta. So then
If theta is equal to 0, then r
theta
should
equals
be
to 0 gives me like
a epsilon plus small a epsilon plus a.
no, we can actually write in terms of minima or maxima, right? Like minimum value of r and maximum value of r. That would be helpful.
Yeah, r min and r max.
So what I can do, yes. So when cosine theta equals to 0, then it's maximum, right? Sorry, minimum actually, like divided by the maximum thing. So r min can be
I
written
think
as that
when cos
constant
theta is equal
divided
to
by
-1, then
1
it is maximum. Yeah.
Oh, sorry.
Yeah, there is a
Cosine theta
minimum.
equals to this is the minima, yeah.
Yeah, and
Yeah, this
for
thing becomes
maxima,
1, yeah. So
yeah, that is a
and
plus
for
a divided by 1 minus
r
epsilon.
max, a divided by 1 minus epsilon, right? So this is what we can get. So for an ellipse, this is like the maximum and minimum distance from focus. So if you draw it, then if it is on focus, so this distance is r min, r max, and this distance is r min, right?
Yeah.
And the distance is r max. So how do we get the other parameter?
Well, we can find the ratio. No, not ratio.